Hi, hello. Welcome to a Clumsy computer video where we will be programming a regex engine. That's what we will be doing today. We're going to be doing it from scratch. It'll be around 200-ish lines of code. It's going to be in Python, and we're not going to have any imports. So no libraries. We're not even going to import anything. We're not going to import anything at all, which will be cool. Now, I want to first tell you what we're actually doing. So hopefully you know what regular expressions are, otherwise this won't be super interesting, or maybe it will be, but basically regular expressions are a small kind of mini language that allows you to match little pieces of text and other things as well, but generally that's what you use it for. So basically we will be, let me show you, let me just draw really quickly here what we'll actually be implementing, because there are a bunch of different types of regex engines. So let me just draw here. I have this convenient drawing surface. So basically there are kind of two types of regex engines. More or less, and they're kind of called, like, I think it's text, it's something else, it's not oriented, but it doesn't matter. They're called like text oriented and regex oriented, something like that. Text something and regex something. In any case, the difference between the two, and now I realize that my camera is blocking the text, so let me just do that. The difference between the two is there's the implementation, so how it's implemented, and then the second thing is what they can do. So basically, text-oriented engines will be more, so let me just, yeah, they will be more, let me just draw a line here, let me just draw a line here, excuse my drawing ability. So these are more simple, and these are more complex. So what that also means is these are faster, and these are slower, as far as how long it takes to run. And then another thing is these are kind of, I would say, less powerful in terms of what you can actually do with it, and these are kind of more powerful. And then this text-oriented approach usually uses an NFA or a DFA, and I'm going to explain what that is in a second. And this usually uses like backtracking. Okay, so what does all that mean? Basically, there is a simple way to do regular expressions, and the way that you do that is you can convert your regular expression into what's called an NFA or a DFA, and that is a non or a deterministic, just the NFA is the non, and then the D is the deterministic finite automaton. Now that sounds super crazy, okay? Automaton is just a fancy word for machine. Finite means it can only have a finite number of states that it can be in, and the deterministic part we're not going to worry about. Basically what this means is that when you have a regex, such as, I'm not going to do it like all completely out because we don't necessarily care about it in this situation, but if you have like A, B, B star, A plus B, whatever, you have some expression like that. Basically what you can do is you can turn that into a kind of diagram like this, where you can say, for example, I can take an A and then I'm in this state, and then I can take a B and then I'm in this state, and then I can maybe take more Bs and then I go back to this state, and then maybe I can take another A and I go to this state, but I need more than one, so then I need to go, you know, and so on and so forth. So basically it's just this diagram of states, and then you can convert your expression into that. And then once you've done that, it's super easy, because there's not many ways that you can go through this. Like it only has a finite number of these nodes. Sorry, this is a node and this is just an arrow. It only has a finite number of these nodes, and you just go through it like basically left to right, more or less, and then you have your regex. Now, okay, why don't we always do that? Well, the thing is, it can only implement what's called a regular grammar. And this goes into like the Chomsky hierarchy of you know, grammars and all that stuff, which you can look up, but we don't care about it that much. The point is this can only do simple languages. It can't have memory. So it can never parse something like open paren a close paren. Like it can never find an a inside parens, because this means that when you find this paren, it needs to remember that it had this before, and it doesn't have any memory. It just goes left to right. So we're just going to put that in the trash. We're not going to do that. So this is this first approach. It's more simple, but it can only do certain basic matches. On the other hand, this regex-oriented approach basically is your classic kind of programming, recursive, let's say, or backtracking approach, where you just literally, you look at all the options. You don't do anything like crazy like that. You just go through everything. And this is more powerful because if you can consider all of the options, then you can say, hey, you know, I want to have backtracking. I want to remember something that came before or something like that. So this is a bit more complex and it's slower. Now, this brings me to my point, which is, which one of these are we going to implement? Let me just draw a line here so that we know that this is separate. This belongs here. Which one of these are we going to implement? Because I said that this one on the left is simple and this one on the right is, you know, more powerful and more complex. Well, it actually, you might be thinking I'm going to say we're going to do the text-oriented one because it's so simple. But actually, the simplest way to get started with a regex engine is to do the one on the right. And that's just because the programming is easier. It's less code. Of course, it's a bit, you know, it won't be as efficient, but we don't care about that because we're just trying to learn. And you don't need to do all of this. So this stuff on the left is super easy once you have the finite state machine thing. But like before that, you know, you need to have that and so on. So basically, we're just going to do the simplest programming wise, maybe slower, but actually even more powerful. This is how regex is implemented in Python, in Ruby, in Perl, and all of these languages. This is the one on the right. Whereas I think the text-oriented one is implemented in grep and in some other utilities. Anyway, this also means that if we want to add support for all these extended grep things, you know, we can do that, but we won't because we don't care about that. We're just going to do something very basic. All right, now that we have all of that introduction out of the way, we're just gonna, for the rest of the stream or for the rest of the video, depending where you're watching, we're just going to do programming. So we've gone to the programming part. All right. So basically, we're just going to start out with an empty Python file. We're not going to import anything. We're just going to be writing into this file, and then we're going to be running it, and we're going to see if we get the result that we want. Drink some water. All right. What do we have to do as far as super basic stuff? I mean, super basic, before we can do anything. We just want to maybe have a main function, so we can just do def main, and then we're just going to say print hello. And then inside this function, or sorry, outside this function rather, in Python, if you don't know this, a nice way to run you might just want to do main here. You can do that if you want, but in Python, a better way of executing something whenever your script is run is by saying if name equals main, then you run main. The difference here is that this also allows you to import the file. So basically, if you only had main outside here, you could never import the file because it would just run it every time. Okay. Another thing we're going to do is, because I want to run this, I'm in Vim, I want to run this directly from my editor right away. I don't want to be opening up another terminal to do any of that. So basically, I'm going to do a shebang at the top of this file. So user bin of Python. All that's saying is run this file with Python. And then I have a hotkey mapped in Vim that will just run this file. Now let's run this file, and you're going to see it doesn't work. And the reason that doesn't work is because I need to chmod it so that we can execute it, and then we run it, and then we get hello. So we're in business. We're officially programming. Nice. All right. Now let's see what we actually want to do here. So let's take an expression, and the expression could be something like, let's just start out with like the most simple, right? We're going to find ABC, and then we're going to take our string, and our string will be, let's just say, well, maybe I shouldn't call this str, because let's just say our string, str is reserved in Python. So our string is going to be hello ABC, and I just want to find if this matches this. Now we don't have any of these like symbols whatever yet in here, but that's fine. We're just gonna do super basic. So now let's see how we can match this. So we're just gonna have a function that's called a match. Let's just say match expression, and it's gonna take an expression and the string. And we also want to remember how long the match was. This is mainly so that we can actually cut it out of the string and show it at the end. So let's just say match length, and let's just return. We're gonna return whether or not we match in the match length. So let's just say true and 0. So let's say matched and match length equals match expr of expr and string, and then we're just gonna say if matched, else we're gonna print. We're gonna say, and let's just do like a kind of nice print here. So we're just gonna say match expr, and then we're gonna replace expr and string here, and we're gonna say equals let's just say true for now, and then we're gonna have something nicer later. False. All right. So if we run this, we can see the missing positional argument because we didn't give it match length. Sorry, this will give us a match length. We don't have to give it match length, I don't think. Right, I'd have to maybe take match length later. All right, so it starts out at 0. Actually, here's what we're gonna do. I know that we're gonna have to pass this in later, so I'm just gonna set it as a default argument as 0. That will be the easiest. All right, so now it always matches. Great, fantastic. All right, now let's see what we can do to find out if this one string matches this other string. Let's do something even simpler. Let's take off the hello at the beginning, and here we're gonna do we're just gonna match the expression ABC with the string ABC, and of course it's going to match. Now what we're gonna do is we're gonna try to match one sort of single character, and we're just gonna call it sort of a unit, let's say. So let's just call it does unit match for an expression and a string. And we're gonna say, for example, return just a super easy option if the first character is true. And then here, what we can do is just check if does unit match expr and string. What we can do is we can return match expr, and here's the main idea here. We're going to return the result. It's a recursive call, so we're going to return the result of this very same function. However, we are going to take off one character is basically the point. So what we're going to do is we're going to say expression of from 1 on and string of, you know, from position 1 on. So basically this just gives us the next so for ABC it would give us BC. And then what's gonna happen is we can't call this infinitely. Eventually we're gonna get an error, string index out of range. And now we just want to say if the length of our string is 0, then we really have nothing left to match. So we can just say, okay, well, that's true, and match length. Now let's see. Now it says true, and then if I make it ABZ, it's gonna say cannot unpack non-iterable non-type object. Let's just print expr and string to see what we did wrong. Can also just debug this real quick. We have Z and C. Oh, because I never wrote an else. And so basically here I'm just gonna say false, and then, you know, if we did the match length, we're just gonna make none. So see, this doesn't match. So we're already on our way. Basically we're matching like super simple expressions. Now we will be basically adding, now we're going to be adding other things than just our letters. So we're going to also be adding some symbols. So we just want to now check whether or not, let's say we want to add a, like, let's see, what do we want to add here? First of all, let's fix our match length, because basically now we want to actually show the string that matched. So if it's ABC, we're just going to show ABC, for example. And now match length here, we just have to increase it by 1, because every time we pop off one character, we're increasing the length of what matched by 1, basically. So we're going to get our match length at the end, and let's just print it to make sure that that looks okay. It's going to be 3, and that's good, because what we can do now is we can just actually print out our string up to position match length. And so this will say ABC, so that's the part that matched. Now, the next thing actually is, let's just add so that we don't have to be at the beginning. So if we have hello ABC, this could also be in the middle of the string. Now, this is important because normally if we really wanted this to be at the start and at the end, we have these symbols, but we're going to worry about that later. Let's not get ahead of ourselves. All right. So we're going to make another function. It's just going to be called match, and it's just going to be x parent string. And what that's going to do is it's just going to try matching every position from the start until the end. And we're gonna do that until we reach the end, really, basically. So we're just gonna say, you know, what should we call it? Let's just call it like index or match pause rather. It can be 0, and then we're gonna say if match xper of xper and string from our match position onwards, then basically. Well, actually, let's just, we need to unpack this first. So match and match length. And we can just say matched is false while not matched. Just do this, and then if, whoop, I messed something up here. Oh yeah. If we matched, then if we match, we want to return, and here's what we're gonna return, okay? Match xper returns whether or not we matched and then the length of that match. But we also want to return the index, our match position, because we want to know if we started at the beginning or at the middle, in the middle of the string. I just also, because even though this is also a video, I just want to stop for a second to say hi to everyone who said hi in the chat and say thank you to everyone who followed on Twitch. So basically, here we want to remember where we matched. So we're going to return whether or not we matched. We're going to return what our match position was, and then our match length. And that's it. And we also want to, well, we want to have a maximum length that we can go to. So right now we'll just make it the end of the string. Later we're gonna change it up a little bit, but right now we're just gonna say max match position equals the length of our string. Is that right, or is that, I think it's, let's just subtract 1 from it. So while we haven't matched and our match position is less than max match position, we'll do that. And then we also want to do yeah, match position plus equals 1. And then if we broke out of that, we're just gonna say return false, none, it's all garbage, we didn't match, we don't care. Okay, now what we have done just a second ago is we want to match at any position in the string. So we're iterating over all the positions where we can match and so on and so forth. So we're going to replace this call now, and it's just going to be match, and we're going to go get match pause, matched, match pause, and match length. And now we can say match pause here, which gives us exactly the part of the string that we need. Now, unless I mess something up really badly, this should match position. Of course it's not defined because it's actually match pause. String index out of range, and I think this is because we went too hard. Let's see if this does it. All right, so let's see what the problem is here. Does unit match string index out of range? That's because one of them is length 0. So how we're going to be debugging this, you have a fix import RE. How we're going to be debugging this is we're going to see, all right. Okay, so basically what happened here is our regular expression, I did this wrong actually, our expression, if our expression is 0, if the length of our expression is 0, we don't have to match anything now. We've matched it, we're done, it's all good. All right, so we've matched everything we had to match. And now basically this should work. However, my positions are somehow wrong. So we're just going to say print matched, match pause, and match length. Right, so that should work. Matched, match, pause. All right, I think I think I just did it the other way around, to be totally honest, somehow. So match pause is 6, and the match length is 3. No, it's fine. So 0, 1, 2, 3, 4, 5, 6. Okay, what happened there? Why are we getting an empty string? Print string of match pause to match length. Oh, I'll tell you why we got an empty string. It's because I forgot to add match pause here. So we're just gonna add that on top, and now we've done it. It's the world's simplest regular expression. It's ABC, and we found it in a string, and we can make the string whatever we want to, and we're just gonna find ABC inside this string, basically. There we are, and it's saying ABC at the bottom there. Returning the string, yeah. Was returning the wrong thing. So we've matched ABC at the bottom here, it says, so we found it. Now let's see what we want to do next. I think the best thing to do next, just so we have the fewest headaches in the future, is we're going to add stuff like this. We're gonna add ABC, like we're gonna add A or B or C, or so let's say HHEE, low. So it's gonna match hello, it can also match hello. Now, let's see what the thing is here. So first of all, we're gonna say else here. Let's just check. So now we're assuming everything is a unit. So we just want to first of all check whether actually the thing that we're trying to match is a unit in the first place. A unit we've defined as just like, maybe it's not the best name, but it's what we have so far. A unit is just a letter or like a chunk that we match at once. So it can be, for example, it can be an A, it can be an ABC, that's also a unit, or it can also be actually A or B later, but that's gonna come later. So this is basically what we're trying to pop off, because we pop that off at once. And the reason why are all of these units is because we can have a star after this, we can have a star after this, we can have a star after this, or we can have a plus, or sorry, a plus, or any of those things, right? And this matches the whole thing. So whatever this is, we want to take it off the top. So basically what we're going to say is, first things first, we're going to have to split our expression. So for that, we're going to need a couple of functions. We're going to say is a unit first of all, for a character, and then here we're going to return, let's just say for now, character.is alpha or character.is digit. Is digit is called is digit, but actually it matches numbers and strings. Why did I name it that? I don't know. All right, so this is just a unit for now, and then we can add other characters. It's not a problem, but let's just make it the simplest. And then we can also say is open set is what we're gonna call this open little square bracket here. We're also gonna do is close set, and you can of course also just like define these, just go like if x_0 equals whatever. You can also do that. I just find this a bit nicer because then you know exactly what we're doing. We have a bunch of functions that are making our code a bit longer, but that's not a problem. Okay. Now, what else do we need? I think actually we don't need anything else. Now we are ready to split expr. This is going to take an expr and it's going to split it into head, which is going to be this head that we're taking off, our operator, and then the rest. So we're just going to say head is none, operator is none, and the rest is none. And let me just tell you what I mean by this. So if we have, let's say ABC star XYZ, okay. Now this would be the head, this would be the operator, and this would be the rest, right? So it'll look like this. The reason is that when we parse one chunk, we care about what the head is because that's what we're trying to pop off and match. But we also care about what the operator is because maybe it's more of them, right? The rest, we're just going to chunk together. We're going to deal with that later. Okay. Now, this should be relatively simple. So we're just gonna say if is open set of expr of 0, right? So if the very first thing is an open set, then we want to do that first. We want to check for that. And let's just say what the head end position is. Right now it's going to be none. It doesn't matter. Now, if this is an open set, so this means we're looking at something like A, B, C, D. Okay. So our first character is this. We want to get the set end position, or we can actually just do head end position equals what is it, expression dot find end square bracket. This will just find this thing, and then I think if we do substring we need to add 1. Do we? Let me just look that up. Yeah, we're just gonna have to add 1 to that because it's exclusive. So basically, this is where our head ends, and then we're just gonna say head equals our head equals basically the expression from 1 to the head end position plus 1, something like that. I'll see if I messed that up. So this is our head. If this is not true, and then is sorry, I just realized, do I want to name it like this, or do I want to say, yeah, let's just for now let's leave it like, let's just name this a literal. And then, because if you think about it, you know, let's leave it like that. Actually, I'll show you later what I meant by that. But actually, we can have multiple kinds of units. It can be a literal like that, or it can be multiple things. But let's just say we're gonna leave it. Well, let's think about it. Okay. So no, here's what it is. In does unit match, we're gonna include both these like ABCs and these sets. So a unit is both of those. So actually, this character is really a literal. This is just really what we call a literal. And if this character is a unit, means is it either, and this actually we can do for multiple, we're gonna check the head if it's a unit, which we're calling either an A or an ABC right now, either a set or just a literal. It's either is literal, and this is gonna be just a term, and is literal, the first thing of the term is a literal, or it's a set. All right, hope that makes sense. So basically it's a term if it's either a literal, so just ABC 1 through 3 whatever, or it's a set. Okay, what does it mean to be a set? It just means that we're just gonna say the first thing of the term, organically sourced Python code, no JML libraries. Absolutely, that's what we're doing here on stream. Guys, again, thank you so much everyone who followed. So basically this term, our first thing of the term is going to be an is open set, and then our last thing of the term is closed set, is going to be a closed set basically. So it just starts with a, I'm just like making this kind of very kind of nice to read, hopefully, is the first thing an open square bracket, and is the end a closed square bracket. All right, cool. So now we know, is this a unit? That's fine. Now let's take this head out and see what our head is. So if it's not a unit and it's a literal, if that's a literal, then we're just gonna say head end position is just 1, because it's just, you know, it starts at 0, it's of length 1, 0 plus 1 is 1. Right, and so, and then our head is going to be expr of 0, we're just, let's do it like that. Yeah, basically. So we have our head. Our operator for now is going to be literally nothing, and then our rest is going to be head, string from a head end position onwards, and then that's going to be our rest. Yeah, so we're just going to return our head, our operator, and our rest. You know what? We're gonna do an extra thing. I said we're not gonna do it, but we're gonna do it. I lied. All right. Here's what. We know already what operators look like even if we don't implement them. And we want to test this code once and not twice. So let's just implement the finding the operator. How long is it going to take? 1 minute? Longer than it took me to say this. So a bit shorter, I mean. So now we're just going to say is star. So this is our like matching star thing. I'm just going to copy paste that a couple of times. And is it a plus? And is it a question? Just the question mark. I'm sure these things have fancier terms. All right, and then we're gonna say is operator, and then we're just gonna say is star, or is plus, or is question. Cool. All right, just make sure we're not. All right. Now we're then going to do if. Here's another thing. Well, let's do this first. So basically, if is operator expr of head and position, then we're gonna say operator is expr of head and position, and then head and position, we add one to it. Now, as you can see, we're incrementing the head end position when we find an operator, so that doesn't make sense as far as naming goes. So this is not really the head end position, it is the let's just say our head end position. We're gonna replace with last expression position, the last position we found in the expression. So now we have our head, we have our operator, we have our rest, we're ready to go. So now let's just do something very simple. Let's just print split expression, and we're gonna do ABC, and then we're gonna do a 1 2 3 BC, and then we're gonna do a star BC, but then we're gonna go crazy. So whatever we can find, you know, add a star there, add a plus to that, and then maybe we have no rest. Let's say let's do all of those. Then we're gonna return just so we don't run code that now probably is gonna break. So let's see what we get. Expected an indented block. Now that's not good. That's not good. Where did that happen? So line 74. Yeah, because I never wrote this else. Basically what I want to do here is I'm just gonna say if we here we're gonna run through all of the matches that we can find, and if we can't find anything else, we're just gonna print out an error so that we know, and then we're gonna say unknown token in, sorry, let's just add an F in expr. Yeah, I think that's fine. So okay, run it. String is not defined. Whoops. So split expr. Do we have a string in here? Yeah, so it's expr, not string. All right, let's run that. Okay, so as you can see in ABC, that is completely wrong. This is not what we want at all. It's not even close, guys. Really, if you think about it, it's not even close to what we want. This is bad. This is not good at all. Okay, so let's see where we messed up so badly. Let's see where it went so wrong. I think I know where it went wrong. It's because yeah. All right. It's because I never initialized this, and it just had like some garbage value in it. So, or no, I actually did initialize it. That's funny. So, let's see why that happened. Let's see what our what could have happened here. Let's print out our head here real quick and print out our last expression position. -1. Well, so it's not detecting the first thing of this expression. Let's just print out this expression to begin with. It's not finding the first thing as any of those things. So it's ABC. And it's not finding that as a literal, which is a bit hard for me to believe. It's a bit hard for me to believe. I'm just going to say print is literal, expr, the first thing of this expression, is it a literal? It's a bit hard for me to believe, and it is a literal, but still our last expression position is, oh, huh? Is it also an open set? Is that the problem? Oh, I see. Oh, this open set is messed up. I don't know what we did here. Yeah, well, here's our problem, right? We forgot to compare the string. We just returned a paren. And we did that same mistake for all of these, so whoops. It's gonna be a big whoops right there. Big whoops. Alright, just delete all those prints. Right, and now you can see it works perfectly. For ABC, our head is A and our rest is BC. For, oh, it doesn't actually, it almost works. It almost works, but I just a couple of the numbers are off. So basically for the second one, we're expecting to also get that beginning. I accidentally wrote a 1 here. I don't know why I did that. And then actually the rest is gonna start out from 1 over. So last expression position plus 1, because it's not the last one, but we start from the next one, not the one that we've already seen. All right, so now I think it's good. So our head is A, we have no operator, and our rest is C. Okay, no, that wasn't it. Sorry. Our problem was here, I needed to add 1 there because this is the position of this closing bracket, but I actually want to go to the next after that. Right. So now it's still wrong for some reason. It's because, let's see. Oh, okay, so we're going, our head is going 1 too many somehow. It's, oh, right, okay, of course, because, yeah, we made it +1 and then we need to change it in the other place. Okay, now it's fine. You know, just plus and minus 1s. Okay, so for ABC, our head is A, our rest is BC. For 1 through 3 BC, our head is 1 through 3, we have no operator and it's BC. For all the other ones, we have operators. Our split expert works fantastically. It's just what we wanted, it's just what we needed. It's all great. Nice, we can celebrate. So now we can say in match expert over here, we're just gonna go head, operator, rest is split expert, and we're gonna say if is a unit expert of 0, then we're gonna do this, and this should literally do the same thing as before. Okay, perfect. So now it does the same thing more or less, but actually now it's saying unknown token in expr, and you're just saying you can just see it's taking the first token, and the first token is our open bracket, and of course we never told it what to do with that, so we need to add that functionality. Basically, what we want to now do is not if it's a unit, or well, did we add the proper definition to is unit actually? Because I think it should, or is set term. Oh, I see the problem. So we're passing to if is unit, we're passing the 0, but actually want to pass the full thing, right? So now, let's see if this is a unit, let's print it, and it's actually still not saying is unit. Let's see why that would be. So let's print out our term that we're checking on. And this is our term, is set, oh, I see what the problem is. Okay, we're just gonna do a quick little cheat, and we're just gonna say, well, actually, here's the thing. We're using expr here, and we just need the heads. That's why we wrote split expr. Okay, this is much easier. So we just pass in the head. That's the whole reason why I wrote split expr, and we don't have to worry about anything. So now what it's doing is it's taking our input. Good job us, we did it. It takes our input and it just says false. The reason why it says false is because it doesn't know what to do with those parens. It just sees it and it goes, you never told me what to do with this guy. I guess I don't know. I'm just gonna say false. And the reason is does unit match. Of course, does a unit match is going to return false because, you know. So let's just add a case for that. So so first of all, we're going to do this again. It's slightly inefficient to do this a second time, but it's not, it doesn't cost a lot. It's like a simple operation, and the alternative is just passing a lot of arguments around their functions, which we can do. It's fine. It's just like less clear, and what I'm trying to do here is to make it as clear as possible. By the way, since, you know, if anyone has any questions or is confused about what's going on, you can feel free to ask in the chat. definitely, and if I know the answer, I'm gonna let you know. All right, so basically, what we're doing here is we're gonna take the header operator and rest again, and then we're just gonna say if is literal head, we do this, then we do that. Otherwise, if it's a open set, or even if it's a set, we can say, then we're gonna say, we're just gonna write some easy code in there, just say pass for now, and then we're just gonna say L, or not even else, just say return false. Now, how do we match this set? Extremely simple, simplest thing in the world. We're just gonna go somewhere around here, pick a nice place for our new function, and we're just gonna say split unit, not a unit, excuse me, split set. It's gonna be a set. Well, set is reserved, so we're just gonna say set head, because it is a head, I guess. And we're just then gonna say, it's very simple, we're just gonna say set inside is going to be set head, and we know that it has this form always, so it's going to be open bracket some stuff and then close bracket, and basically we're just going to take it from 1 to -1, and then set terms is just going to be set inside. We're just going to split it you split every character out, and then just return split set, or sorry, return set terms. All right. And now here what we can do is just say return, or sorry, a set terms is split set of our head. And now these are just basically what this returns is if we have ABC, this will just return ABC. And now the easiest thing in the world, we're just gonna return string of 0 in set terms. So is our thing in there. And now empty separator. Now that's definitely strange. Oh, right. So you can't do that. I think you just do list of, is that what you do? Let me just check actually. So basically if I have ABC, I can't do this. No, I swear it worked in a different version of Python. Can I do a list? Yeah, you can do a list. All right, so that worked. However, now our match is still saying false, and the easiest way to debug this again, we're just going to print expr string here and see, sorry, not here, but rather here, and we're going to see what happens. All right, well, that's not good. Okay, and here's why. The reason why this broke is very simple. Do you remember when I said at the beginning of the stream, hey, here we're popping off 1, but actually we're not going to necessarily want to do 1. We're going to maybe do many of them, because there's expressions that are longer, there's units that are longer than just 1 character, for example our set. Here we're just going to do it very simply, we're just going to say match expr of rest, the rest of our expression. Now the string, on the other hand, is very important. The string, we only match 1 letter at a time. This is what makes it simple, right? So we only match 1 letter of the string at a time. So we do pop off only 1 of the string. However, in the regex we can have however many. So let's try this. And it looks like I messed something up. Yeah, okay, I just forgot an if here in split expr just in case the length of our string is so for example our string is too short. So let's just say if last expr position is less than the length of the expr. Is that what I want? Maybe. Yeah. And you can see we've done it. Easy. Absolutely easy. Let's just remove these, or yeah, I'll just remove these, comment out these logs here. And you can see that we've successfully implemented what's starting to look a little bit like a regex. It's starting to look like a regex. We've successfully implemented something that matches not only letters but also classes. So now you can say, you know, A, B, C, D, X, Y, Z, 1, 2, 3, and then I can say dy2. Watch this not work. It does work. It says dy2, and actually now, because of our match function, we can also say, hey, the thing is dy2. Thank you. And It will only match dy2 because it's the only thing in that string that matches that pattern. The only thing in that string that matches that pattern. All right. Now, let's think about what else we want to implement. Of course, the big thing is having stars and question marks and pluses and all that stuff. However, we may not want to do that right away. So let me have a look. So what else? We may want to do the dot, but let's do the dot first. Let's just do the dot first. So the dot matches anything, any single character. So yeah, let's just do that. I think that's the best. Let's just do the dot. So it's very simple. We're just gonna say, let's find the place here. Just say here, def is a dot character. Just gonna return if it's a dot. Simplest code you've written in your life. Okay. Now, again, a dot is also kind of a unit. See, this is why the thing is, okay, the reason why we can make this very easy is because I thought about the structure beforehand. And when I just first starting like writing this the first time, I was like, how do you structure this? And it was starting to look complicated. But the thing with these kinds of problems is if you structure it in a nice way from the beginning, it's so easy, right? And so here we've structured it in a way that will at least make it easier for us. And so we can just say it's this unit. We have this concept of unit. So we can just say our unit can be a literal or a dot or a set. And then it'll accept our dot. And now we can test this. Spoiler alert, it won't work just yet. You see d dot 2, and this dot is going to be a whatever. It's going to be a w. Why not? Okay. And now, I mean, I was expecting it to break, but this broke in a different way than I expected. So let's see. None-type object is not subscriptable. Is that because of the way we split our expr? I think we might need is a unit here. Actually, I think we might say is a unit. Let me think about it. Yeah, let's just say it is unit right now. I think actually, you know what? We're gonna go crazy. We're just gonna not care. We're just gonna say else. We don't care. The reason for that is we're just gonna say, so this is the literal, it has length 1, a dot has length 1, and so on. We might add something in the future that has length 1. If I say else here, okay, in the future it might break. It's possible, could be. But we're gonna know about that, and we're just gonna say, instead of now saying if it's literal or is unit, or units have different length, so it's not, we would have to introduce a different concept. So let's just say else. It works. Okay. And now it's not gonna match, which of course we knew, because the reason for that is that doesn't know what to do with the dot. And now what do we do with the dot? Well, it's very simple. The dot, if we just, it's a unit. And for matching units, we have does unit match. And how we do that is very simple. We just say, if it's not a literal, if it's a dot, guess what? We're going to return true every time, because that's what a dot does, right? Okay. Run it. Oh, we've got it. And you can see that for the first time so far in our implementation of this, we've gotten back. So it's returning dw2, but we never said anything about w in our expression. We just said dot, it can be anything, right? So this shows you that it's actually really like starting to take shape, because that dot, it's correctly sort of finding as this w in our expression. All right, in our string, I mean, rather, sorry. Okay, guys, now it's time. I think it is time to implement the operators, to implement the star so you can have multiple things. Now, I'm going to say two things here. First of all, probably I'm going to mess something up. And secondly, I'm going to look at my implementation that I did before, strictly because to make it kind of easy, it has to be structured in a particular way. because if I structure slightly wrong, it's going to be kind of annoying. So let's just take care, and I'm going to be checking what I wrote beforehand to make sure that we get it right. So let's say let's see what we need to do in our matchExpr function so that we can find these operators. So let's just start off very simply. Before we do any of this unit stuff, we're going to say if is question operator. So just, I don't know, let's start with the star. If it's a star, else if it's a question, if it's a plus, let's just do like descending, else if it's what do you call it, question, if I can spell question, we're gonna return match star of expr string and our match length, which we're gonna pass on. Sorry, match star, not stir. Same here, same here. It's gonna be match plus match question. And you might be wondering, why am I doing all of these at the same time? Why don't we just go one by one? Well, here's the thing. If you think about it, if you just stop for a second and go, huh, the star and the plus and the question are the same thing. It's the same thing. The only difference between those three things is what's the minimum and the maximum length. So a star, just to refresh real quick, in Regex, a star matches 0 or more, so any number basically of a certain term. A plus matches 1 or more, and the question matches 0 or 1. So basically, for star, our interval is 0 and infinity. For plus, our interval is 1 and infinity. And for question, our interval is 0 to 1. So we can just write a single function, and then we just kind of tell it, hey, don't look for the whole thing. Just look for like, you know, less or more or whatever. All right, and we're going to call this function, well, we're going to write these functions first. We're going to say match star. And we said it takes expr string, match length, easy. I'm gonna copy it, say star is plus, this is question, make some new lines here. And all of these are gonna call match multiple. Again, easy. I'm just gonna give it all the same things, but here we're gonna say a star can have a minimum of none, I guess. And it can have a maximum of none. That's just to say we don't care. That's just how we write, hey, I don't care, just so we know later. A plus can have, oops, okay. A plus can have a minimum of 1. That's what a plus is. And then a question can have between 0 and 1. Easy, easy programming, okay? Now we're gonna move on to a match multiple. I'm gonna pause for a second here to tell you, so it's min match length is none, let's say, and max match length is none. I'm just gonna say pass here, and I'm just gonna stop for a second to say something important about this match multiple and why here you really see why what we're doing is a kind of a backtracking implementation. Because what we're gonna do here is, before it was recursive already, but we said if it's a unit and it matches, just pop one thing off and then continue with matchExpr. Now, as you can see here, we're returning now. We're not returning matchExpr anymore here, or at least not right now. We're returning match star, match plus, or match question. We're really returning match multiple. And then the reason, how are we going to get back into what we were doing before? The reason is because we're going to call matchExpr again inside this, because if you think about it, if you have A, B star C, what you kind of want to do is, let's say if you have A, B, C, and you just say, okay, this matches, this matches, this matches, you just pop them off. But here, it's not enough if you match a B for multiple. It's not enough if I say, okay, I have a B, it matches, because I also have to check that everything after that matches. For example, let's say I have A, B star, B, C, for example. If I just now said in match multiple, I'm gonna eat up as many B's as I can. I need a B, I'm gonna grab all of them, I'm gonna grab the maximum number of B's. That's bad. If my logic stays at that, it's kind of what we're gonna be doing, but if our logic stays at that, It's not good, because then we're going to miss out on this B. We're just going to say, if our string is A, B, 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 C, we're just going to say, pop the A. Okay, and we have as many B's as possible. So we're just going to say, kill all the B's and kill this. But we still have a BC to match. This is our expression, and this is our string. So basically what we need to do is, after we've matched our expression, we need to call back into matchExpr and say, hey, by the way, will the other stuff match as well? So we need to simulate. So we say, okay, we have 5 B's. We need to simulate, okay, what happens after that? Did we mess up by eating too many characters? Now, what happens here though is, of course, what you could do is you could just, and this is where I'm gonna have to look at my code just for a second, is because you can just as well say, okay, well, I'm gonna start matching a B and then check everything after, and then if that's good, I'm gonna match another B and then check everything after that. But the point there is, you're matching all of the rest of the expression every time. So we want it to be a bit more efficient. I know I said we don't want it to be super efficient. That's not the point of the stream, but we don't want to go crazy, okay? We want it at least to be decent, okay? So we're just gonna, when we match multiple, we're gonna check that the next part of the string still matches the star that we have, and then we're gonna, only then are we gonna return. So let's see. Basically, what we have to do to begin with is, as before, we need to do our head and our operator and our rest. It's just gonna be split expr, because we need those as before, basically. Now, let's see, our minimum length. If we don't have a min match length, we're gonna set min match length to 0. So that means we don't care. We're gonna start at 0. Now, on the other hand, for the max match length, we're just gonna do it in the loop later, because you know we don't care, and so we're just gonna not really take it into consideration if it's none. Now we're gonna step through the string and see what length of a submatch can we find. So how, if we have this thing exactly here, how many B's can we match? So we're just going to call that submatch length, and that's going to be, you'd think it's going to be 0, but actually it's going to be -1, because I want this variable to be the length of the longest submatch that I've matched. Now I haven't actually matched 0 because I haven't checked that 0 is okay. So it's important to remember, okay, well, what is this actually? What is this value actually? What do I mean by this? Is it the position of where I matched one, or is it the next one that I'm gonna match? Because otherwise you have these off by 1 errors. You can fix it, it's no big deal, but like it saves you some headache. So right now we've not even matched a 0. And then what we're gonna do basically is we're going to say, let's think about what we can do here. Let me have a look. So basically, right, we're gonna try to match our head. So we're gonna do matchExpr with whatever it is that we popped off. So our, basically, let me write it out. So first of all, we're just gonna say, while either we don't have a max match length, so either not max match length, or our submatch length is less than our max match length. That's good. That would be good. We're gonna do the following thing. We're going to say, can we match our B, let's say. So okay, let me do an example. So we have A, B, 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 C. We're just gonna say, okay, we've popped off the A, we've reached this point. We want to see, and we're gonna ignore the C for now. We're not gonna delete it, but I'm just gonna move it away so you don't. We're just gonna say, do these B's match this B star? And then we pop one off, and then we say, okay, does it still match? You know, how many can we match? And then a way to do that is we're now gonna start expanding our regular expression here. So when we have B star, this can either be, we're going to test the cases. We're going to test, will it, so string 1 is going to be either like blank string can match here because we have B star, so that can match. B can match, right? BB can also match. And now, do you remember what I said earlier that, okay, it doesn't really make sense to check the whole rest of the string? We're actually not doing that, if you think about it, because I'm the only expression, I'm not going to pass in all the rest of the stuff. I'm just going to pass in our star thing here, but expanded. So we're just going to have 1B, 2Bs, whatever. So basically, if you think about it, this star can affect a B or it can affect an ABC. For example, it's a head. That's the notion of head that we had before. So what we're going to do is very simple. We're just going to say submatched matched, and submatch length is going to be match our expression. And let's think about what we need to pass in here. So we said our head, basically we want to say B, 2 B's, and so on. Or in this case here, we want to say ABC, ABC, ABC. We're just going to expand this out. We're just going to, like an accordion, just add, you know, duplicate it until we can't duplicate it anymore because it doesn't match. So what we're going to do is we're going to take our head, we're going to multiply it. And remember, in Python, if you have a string, it's kind of weird clearing of the screen there, but okay. If you have a string and it's hello, if you multiply that string by 10, let's say, you get 10 hellos, which is very convenient for us. It's really good because that's what we want to do. So we're just going to multiply by our head by this submatch length. And it's actually, remember I said that this is the one we'd like to match. So submatch length is what we've matched so far. And this is the one we'd like to try to match. So we just add a 1. That's our expert. And then our string is just going to be our string. We're matching the same string. We're just matching the start of it. And then our max match length. Now, what do we do about this? What do we add to that? Do we add a 1? I think we add a 1. Because really, we're just, our submatch length is matching 1 character. So if I'm not mistaken, let me check. Oh no, sorry, we don't add anything. I just realized because match expert will take care of that for us. So we don't even have to add anything. This is it, basically. Right. And so we've done this expansion, which is kind of the most annoying part of the process, honestly. So this was kind of annoying. I claim, right? So because you have to expand this and remember that, like, basically, you know, if you have, I'll just say it again because I'm not sure that it's super clear, but if you have A 1, 2, 3 plus C, what can this be? It can be A 1C, A 2C, A 3C, A 1C, A 12C, and you know, I don't have to do the rest, you get the point. Now you may be thinking, hey, what are you doing? You're doing so much. You're checking all of these things. And that's where I'm saying that this approach is not the fastest. However, before you go, what the heck, this is the same approach. Of course, I assume that this is a bit less optimal, but still, it's more or less the same approach that is in the Python regex module, in the Ruby regex module, in the Perl regex module, and so on. So this is the most frequently used regex kind of implementation. Okay, so it's, which is just to say it's not going to be horribly slow, and you'll see that in a second. Okay, so if we matched, then we're just going to say submatch length plus 1. Hey, cool, we matched another one. And then we're just going to say if we didn't match, we're just going to pop out of this loop. All right. So basically, we've now found the longest match, and I forgot to explain why we're doing the longest match, because you might be thinking, hey, you know, A, B star C, you know, you can just match AC, or you can just match like whatever shorter. So let's just say it's A, B star, and I have this. What we want to match is this thing. We don't want to match A. Now you could say, if this is our expert and this is our string and this is our result, it's not wrong. It's not wrong, right? Because your expression is just A and whatever number of B's, and in our string we have these B's, but we can just say, okay, we matched A, see ya, bye. But you know, that's not usually what you want, and it's not what regex engines usually do. So the kind of general rule of regex engine is you return the longest of the leftmost matches. So it means you start from the left, you find all the matches from the left, and you find the longest one. Okay, cool. So we've done that. Now this was all to identify if you notice here, I'm not doing anything. I'm not returning here. There's no return. There's none of that, because all I did here was just to find the longest length, which was the hardest. Actually, I think the hardest thing in this whole regex implementation. That's not that it's hard to code, but like it's hard to think about, because you're saying, okay, I want to find the longest length. I expand out my string, and so now what we can do is, basically, we can also take the rest into account. So we can go from that longest match of our repeated character and go backwards and see, okay, which is the longest of those. So this is the longest sub match, right? It's the longest sub match. So we have A, B, 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 B as the longest sub match. Now here, the longest sub match is going to be this. But we don't like this. This is no good because we missed out on this P. That's what I said before. So we want to now just go back from that maximum length and find the length that's actually good for matching. So we found the most B's we can add. We've added all the B's. And then we're saying, okay, but let's calm down for a second. Let's make sure we don't ruin the rest of the expression. So we're just going to say, we're gonna kind of loop forever because we're going to break, but I'm just going to add the thing in saying while our submatch length is greater than or equal to our min match length. Strictly because you don't, if we're matching, in any case, we don't want to go below 1. We can't have a -1. If it's -1, we return false, right? But we also, if you remember, sometimes we have a min match length and we have a plus, and that plus we have to take into account. Because if, you know, we match 0 and we have a plus, but the plus wants a minimum length of 1, that's no good. So we're just going to make sure. And then we're just going to say, I think we just do matched and match length already, unless I guess it doesn't. Yeah, I'm just going to say new match length. I'm just making sure that I name these things. I'm just checking. So I don't want to name it anything that will like be annoying in the future. Even though, you know, we've done a lot of, we don't have a lot to go, honestly, because this is the hardest part. And now we're gonna say our head times our submatch length. Again, this time we don't multiply by -1 because we already have the length. It's not a hopeful length. It's oh yeah, and another thing, it's not a what do you call it? I just realized I made a mistake here. It's the length that we actually know. So this is actually, I just passed the wrong thing here. It's not max match length, but it's match length. And this is the same because it's not, you know, that doesn't make sense. It's just the match length that we have so far. And again, especially if you're just joining, if you're wondering what is match length, why are we passing it around all over the place? The reason for match length is that at the end, we need to know where we started matching and what the end of our match was, so that we can find, I feel like I've said match so many times already, oh my god. So that we can find where inside the string we need to slice to get out our nice match. Okay, I'm just gonna say if matched, return matched new match length. Otherwise we're just gonna keep going, I think, and yeah, basically we're just gonna say submatch length. We take 1 off because we go like to the next longest one, and then at the end we just say return false, none. And just a reminder again, we're returning false and none because this is, as you can see here, it's the same. We're returning the same kind of thing because these functions are calling each other. We're returning how did we match or not, and what's our match length so far. So we're doing that. Now, I don't think we're actually are we calling match? Do we still have to do something? Have we done it? I don't actually remember. So let's just see, did we break anything? This works. Now we're just gonna say A, B, C, and we're gonna just do A, B, C. Just making sure that we haven't forgotten anything. We need more than 1 B. Okay, match length, something definitely, you know, we broke something somewhere, but that was expected. All right. Well, that's because I forgot to write length there. That's a bit silly. I remember this. So this is not supported between instances of none type and int. This is because min match length can sometimes be none. sorry, was that match max length? No. Sorry, submatch length is none type. Right. See, this is why I was checking the variable names. I used the name twice. It's no good. Let's just say submatch. It's not really a submatch, it's a sub expression because we're doing a smaller part of this expression. So submatch here, we're gonna replace with sub exper. Let's see. Is that right? I think that's right. Sub exper length, reference before assignment. No, that's definitely that's not what I was expecting. Oh, right. Am I using this somewhere else? No, sorry. Yeah, I've replaced too much. Anyway, this is just a variable naming thing. Right, and now match length is not defined on line 96, and that is because I somehow undid my previous change of naming this variable, which is very strange. Okay, and now we've matched it, kind of, and let's see if you can spot the bug, because I already know what it is, because while I was writing this just a second ago, I was thinking I better not forget it, and I forgot it. As you can see, let's debug this together just so we see what went wrong. So basically, we have a more than one b, or sorry, more than 0 b's, one or more b's, and then a c, and our string is abc, and we're only matching a b. That means we're stopping, and it means we popped off our c accidentally somewhere, and I'll tell you where we popped it off. Can you see it? Can anyone see it? Can anyone see what we did wrong? What happened here is, here in the first while loop, we're only matching, you see it's sub expression, so that's our sub expression. We're only trying to expand out this like multiple match token thing, so expand out this plus or whatever. All that we're trying to do is we're trying to expand this out and find the longest one. But here, that's not true anymore. So this is the submatch length, but this is a proper match. So from now on, we're trying to match all the rest of the string. We're doing, okay, we found out the longest length that we can match, and then we're saying, all right, take this longest length expansion of our term. So if our term is A, B star C, the longest one that we can match is A, B, 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 C, whatever. This is the most B's that we can stick in there to get the longest match. But then we really want to continue matching as normal, so we need to add the rest onto here. That's the C. That's the rest of the match that I left out. And remember, right now, this function needs to call back into matchexpr and return what matchexpr is returning. So we're basically in the middle of this chain of function calls, and if we leave something out now, we're not just returning true or false. I mean, we're returning false if we know like everything's gone wrong, but we're not just returning true or false. We're returning the result of subsequent matches as well. And if in those subsequent matches we've left out the rest of our expression, then that's no good. All right. So just to go over what we've done here, we've made sure that our minimum and maximum lengths for this operator, for this star or plus or question mark, are as they need to be. We found the longest string that we can match, and then we're now finding the longest expression inside the whole expression, or the longest string inside the whole expression, and matching the rest of the expression, you know, for everything else. That was confusing, but what I mean is, just like I said before, we're finding the longest submatch, and then we're putting everything after that. And now it matches ABC. Have we implemented regular expressions? We're not done, don't worry. There's more to come. But for those of you watching on Twitch, can we get some PogChamps in the chat? Because I think we just did the regex. If I take away the B, doesn't match. If I add another B, says I got you, A, B, B, C. If I do a star, it says okay. Then I take a B off, it says okay. Then I take another B off, it's like, oh cool. Okay, you wanted to match 0. GG's in the chat, alright. That's what I like to see. And so now the question mark, run this, AC, add a B, ABC, add another B, this should fail. And it does. Now, you might be thinking, well, okay, all right, okay, but listen, we had all of this, like, all the stuff with the terms and the units, but actually what we did in the end was very simple. Well, first of all, we're still gonna do some stuff, but secondly, Here's why we had to structure the code like that, because now if I do an A, then any number of 1, 2, or 3, and then a C, this matches, this doesn't match. Now a 1 does match because it's looking inside the set and it's finding the 1. But 2 will match. A 1 and a 1 is gonna match as well. A 1 and a 2 is gonna match as well. In fact, we can just keep spamming 1, 2, 3s until I spam the 4 and that wouldn't work. So 4 doesn't match. Don't know what a 4 is. We add a 4 in here. Sure, why not? It works. Okay? So that's kind of the idea. Thanks, Hopper. I'm glad you like it. And let's look at what we have so far, guys. So we're not going to count this main function because it's just testing stuff. And if we look, if we just use the Vim little bar thing here, if you see at the bottom right of my screen, we're at 155 lines. And we have a pretty workable regex engine already. We've done it. And it's 155. It's not that much. And it's actual regex. But we don't want to stop here, because I'll tell you what I still want to do. There's one more big thing. So if you weren't here for the beginning of the stream, I was talking about how there's multiple different engine types that you can implement. So there's one based on like finite automata, which is not what we're doing here. That's a much simpler, it's a much more efficient and kind of simpler conceptually way, but it's a bit more code, so we're not doing that. And so on. There are also different versions of regular expressions. So there's of course you have sort of ones without these back references, which are sort of the most like the level 1, like the most standard. Then you have back references and so on. There are also different syntaxes. So you know, how do you deal with escape characters? How do you deal with alphanumerics and so on? But what I'm trying to say is, what we are going to do now is we're missing one feature that's important, and it's even in basic regexes. It's even in basic regexes, and it's important. And that is alternates. And alternates are simply A, then cat or dog. Or sorry, let's say 1, cat or dog, and then 2. This means it can be either one or the other. And that's important because it's a feature you want to use. So if I put in 1 cat 2 here, it's just going to say unexpected token. Unexpected token is going to say, I don't know what you want from me. I don't know what your problem is. I don't know what that paren is. So let's add that. So we're going to say, let's just go for is open set here. Is open alternate character, and just say character equals open paren. Add another one, or close paren. So we've done that. I think we might want to add, let me just check just so that I don't add it for no reason. Yeah, we don't need it actually. I was just gonna say if we need the is alternate function, but we're not gonna use it. Whoops, we need an extra space here. Okay, and then let's look at what other functions we're gonna have to implement to implement these alternates. So we've split a set in the same way, in the exact, whoops, interesting, I pressed something. In the exact same way we want to split this alternate, because just as a set from A, B, C, from A, B, C, we're going to A, B, and C. From an alternate, from cat and dog, we want to get, sorry, there's an arrow here, cat and dog, right? Easy. So this is extremely simple. We just say def split alternate, and then just gonna say alternate, and then we're just gonna simply return. Let's just do it. Should we do it? Let's just do it on one line. It's very simple. We're just gonna say our alternate. We're gonna throw away the first character and the last character because we know it's an open and close paren, and then we're gonna split it by the pipe character. All right. And then it's just, you know, it's just gonna be what I wrote before. Very simple. Very, very simple. And now let's see where we have to add this. We're gonna have to add it in a bunch of different places. So is open set, we're gonna say is open alternate, just as we did with the set. This is why I'm saying about the structure. It's not this particular structure. I mean, it's just a structure that it's not like it's just something that happens to work in this situation. But what I'm saying is, if you stop and think a bit about obviously I've had more time to think about this than you because I prepared for, you know, writing this, but if you stop and think about it for a little bit, you can have a structure that then is super easy to work with, and then it makes programming easier, and then you basically, it just makes your life easier. It's simpler to implement it. You have more time to, you know, kick back on the couch and watch Netflix, you know? So we're just gonna say basically last x per position is going to be exactly the same. We're just going to find the close paren, add 1. Our head sponsored by Netflix, I wish, confirmed. Last expression position, I think the 0 can just fall out. Actually, we don't need it. Okay, and now we've actually split this head. This is just as a reminder, we were doing this to split out, to be able to split out this alternate out of our what do you call it, our expression in general. And now this alternate, the question is it going to be a unit? And the answer is this alternate is not a unit. And you may be wondering, and it's a very good question, why is ABC a unit but this isn't a unit? It's important. It's important. So this is a unit. What does that mean? I made up the word unit here. It doesn't really mean anything, but it's just something to say. We can pop this off and match it just as it is. So we can just go bloop, put it here, and say match. Yep, this is what a unit is. We can look at it in isolation. That's why it's called unit. And then match it. However, this, we can't do that. We cannot do that. And I'll tell you why. Because in this case, I'm actually now thinking, is that true for sets as well? Are sets actually not units? Is there a bug? I'm not sure. But the point is, for alternates, definitely you can't just match it like that. And that the reason is you don't know what comes after. So if you have a, you know, BB, I don't know, let's just take like a super simple example. A, B, so 1, B2, you know? What we're going to do is we're going to try out, once we've matched the 1, we're going to try matching 1A, then we're going to try matching 1B, then we're going to try matching 1C, and then the rest. That's because the rest can interfere, just like it did with the multiple matches. Remember when we had too many B's and we had 1B left over that we were supposed to match separately, not as part of our star? It's the exact same thing here. We don't want to match too many A's, or we don't want to match something where it's not meant to match. So what we're going to do here is just the same as we did with those multiples. We just replace this in the regular expression, and now we're going to call match multiple. Wherever we call match multiple, we're just gonna let ourselves be guided by the way we architected this. Well, it's not match. Yeah, here it's the match plus match question and match star. We're gonna say if is wait, actually maybe it doesn't. How did I, maybe it would make sense to implement a is alternate. Yeah, let's just do an is alternate. It's nicer, just like we did is set. It'll just look nicer. Is set is alternate, is open alternate, is close alternate. Same thing, we're just copy pasting the code from the, you know, just match the first bracket and match the last bracket, or paren or whatever. And then here, if is alternate head, if our head is an alternate, and what we're gonna do is return match alternate, x per string match length. Same deal. It's the same thing as with our plus and so on. And then we're just gonna write it in here. We're just gonna say def match alternate x per string match a length. And what are we going to do here? First of all, just like before, we want to take this little snippet of code here that matches our head, our operator, and our rest. And now we want to split this head. So I think we named the function split alternate, and then we're saying options. So all our alternate options, just to say our options, are split alternate for head. So now we're gonna have, you know, for A, B, C, we're gonna have A, B, C, and so on. So now we want to try to match, and we can even copy paste basically everything that we did here. We're just going to say, not a while loop this time, we're just going to say for option and options, very simple. For each one of these options, for A, B, and C, we're going to say, instead of the head, let me just think, do we need the operator? Do we need to add the operator? Let me just check how I did it just to make sure. I think we need the operator, but I'm not totally sure. No, because the operator will be matched. The operator is going to be pulled out. See, so look, here I was just wondering. Let me do it first and then I'll show you what I mean. So we just need our option. Literally, just because here we took our head and we multiplied it. We don't want to multiply anything. Here, Alfino, how are you doing? We multiplied our head because we wanted more, but here we don't want more. We just want our option. That's all we want. That's all we want to do. And if we matched, we're going to return. And otherwise, we're going to say return false none. And actually, we don't need this submatch length because we're just going to do it once. Or yeah, basically we have one thing. Now, what I was thinking is, do I want the operator here? And the answer is, give you a second to think about it. The answer is, of course, we don't want the operator here, because the whole point is that this alternate we could split out with our split expr function. And in our main match expr function, is alternate is after. It's after is star is plus and is question. What that means is, because here our head could be an alternate, and again, an alternate is this like A, B, C kind of thing. So if we have A, B, C, star, this is going to be pulled out into the head and the operator. And then the operator is checked first, as it should be. This is important, because if we had the alternate first, it wouldn't work, because we'd forget about, we just pull the operator out, the head out, and then we pull the head out and pass it to the alternate, but we'd forget about the operator. So we need to do the operator first. It's important. That's what we're doing, basically. Okay. And now let's see this in this alternate, just to recap what we did, match alternate. Basically what we're doing here is we're splitting it up, getting the options, trying each option. That's all we're doing. It's very simple. Trying each single option. And now let's see if I messed it up. Yep, it doesn't work. So unexpected token, which means I forgot. Well, let's just print our head. Let's just see. Is alternate head. We're just gonna print out what's happening here. And it's a simple typo, I'm sure. Right. So our head is going to be, did we not, so our split expr is not working is the answer. Oh, wait, huh? Is open alternate. That's weird. I would expect this to work. So let's just see here, print expr, print is open alternate of expr 0. Let me just see what I messed up here. Expr 0. So that's saying false, which is very strange, because if you look at it, it is an open paren and it's saying false. Okay. Well, it's because, wait, no, it's not even because of that. That's very strange. Did I do it the other way around? That's very weird. I wasn't expecting that. Let's see. Whoa. I think is open alternate. Oh. Well, as you can see, for some reason I didn't get a warning about it, but I defined this function twice, and the second time it was being defined as matching a closed paren. So then of course what was happening is basically this one was getting deleted, sorry. This one was getting deleted, and now open alternate just matches a closing paren. So that was just a very minor kind of code thing. Alright, and now if we try unexpected token, still. Did I mess that up again? Yeah, sorry, that's the same thing. I just did it to show you guys and then I didn't refix it. Okay. And now we're matching, and as you can see, this is starting to look like regex. It's starting to look like regex. let's do something crazy to see. So, you know, let's say, hello, I am a dog or a cat. Sorry, this is our, let's just say, hello, I am a cat. It's gonna match. It's not gonna match. Why is that? Unknown token space. I guess I never added spaces, did I? Yeah, I guess I never added. Let's just add like a little thing here. We're just gonna say character in, and then we're just gonna make a list of things. Already regex? Yeah, pretty much. We're just gonna add a space, I guess. Yeah, I didn't know about the spaces, so it only knew about letters and digits, and it didn't know about spaces. So I just said spaces exist. It says hello, I am a cat. Hello, I am a dog. But now, guys, now let's see if this works, because this is really what we've been trying to do. Hello, I am a. I added a plus after this alternate. See, that's a bug. Stringing this out of range. Let's see. Does unit match 95? Sometimes this unit the literal can be empty. So I think we're just gonna do this in case it's an empty string. I think that can happen. Let me just check. This is just a matter of, oh no, sorry, this is something else actually. Or it's kind of the same, but does unit match? I didn't cover this one when we did it, but like sometimes you can have an empty string. So it's possible because of all of those multiples that we did. You remember here when we said, oh, we're gonna go up to length 0, so we're gonna try to match a length 0 multiple. What the code that I should have added there, because for example, if you have the star or the plus or whatever, you try to match length 0, even though we shouldn't have to do that with the plus. So I'm just gonna check if maybe we did do something wrong, but no, I think it should be fine. You might say that you're trying to compare with an empty string because you're trying to match nothing. So here we're just gonna say if length of our string is 0, there's no way we can match that, and we're just gonna say return false. Because nothing is gonna be equal to like an empty string except an empty string, but if it was an empty string, we wouldn't be matching it in this function. So we're just gonna run it. Hello, I am a cat. That works, but what if I say hello, I'm a cat? That works. Now, let's say I wanna say I am a, and then it's like either a dog with however many O's, including 0, or a cat with however many A's. And we can have however many of those. And we can maybe have a space at the end. Why not? I hope that works actually. So let's just say hello, I'm a dog. That matches. Hello, I am a cat. Sorry, hello, I'm a dug. Hello, I'm a doog. This is all matching our rules, right? Because of this. Hello, I'm a cat. But I'm a kit won't work, right? Because of our plus. Hello, I'm a cat. Hello, I'm a dog. Cat dog. It matches I am a cat. Interesting. Oh no, that's normal because I forgot to do the plus here. Hello, I'm a cat dog. Hello, I'm a cat doog. Guys, PogChamp's in the chat. We've implemented regex. We've done it. This is we've done regex. It's, you know, we've basically done it. Now, what else do I want to add? What else? I do want to add 2 more things, I think. Let me just remember that I want to add anything else because I didn't write it down. So I think it's just these 2 last things that I wanted to add. It's just these 2 last things that I wanted to add. Absolutely. 2 things. First of all, do you remember how and now you implemented more problems? Yeah, I get that reference. That's that's good. So all right, 2 more things we need to do. Very, very, very simple. We've done it basically. Just need 2 little things. So first of all, do you remember when I said, oh look, our match expert is just matching, let's delete this debugging line. Our match expert is matching just at the beginning of the string, and so then I implemented this match function which just steps anywhere through the string and tries to match. Well, what if I really want this to be at the start and this to be at the end, right? We don't support that yet, so let's add that. It's very simple. This won't work, and it's just gonna say unknown token over and over and over. It's because it doesn't know what that hat is. It doesn't know what that hat character is. So we're just gonna do as we did before. We're just gonna say def is start character, return character equals start, and then we're gonna do is end, it equals the dollar, right? Extremely simple. Now what we're gonna do is we're just gonna say max match position. We already have this, so we're just gonna say if is start expr of 0. So if our very first character is that hat, because it's always at the beginning, otherwise it doesn't make sense, we're gonna say max match position equals 0. Sorry, let's just make this match max positions. Yeah, so it would be 0. This would be wait, what's the least confusing way to write this? It could be 0, but then it's less than, and then I have to make it less or equal. Let's see. How did I do it here? So I said there, yeah. Okay, let's just go less than equal. I think this still works. Wait, does it still work? Is this okay? These off by 1 errors are always the worst. So our maximum, position to match is going to be the length of the string -1, unless we have a begin where it's going to be 0, and then we're going to go up to, or we're going to go less than. No, this should work, but here we're going to get a match position. Did we start match position? Let me just, okay, wait. So we start at 0. Either we go all the way up to the length -1, that's the one we want to get to. Let's just make this 1, whatever. And we're gonna go less than. I think this is good. I think this is what we had before. Let's test it, I don't know, okay? So we've done that, and now we need to remember, if it's a start, we're just gonna say expr equals expr, pop that first one off. We need to pop that first one off. Hey X1, how are you doing? Let's pop that first one off from the beginning, and because we don't want that in our regex anymore. So let's see if that works. I think it should work. Let's try something a bit more simple. So our expression is start ABC end, and the string is going to be ABC, just so we can check if that worked. So this doesn't matter. Sorry, the dollar. Okay, we're gonna leave that out. That works. Now this just expression of just C, does that work? That does not work. It should match. So see, we've done a bad thing here. This should work, and this should work. I think this is fine. That matches, right? That matches. So this is fine. And then if I do the hat, this matches. So that's fine, but this will not match anymore. So we've done it. It was easy. It was just like a +1. Okay. Now that works. Let's add, so let's take off the dollar here. So that does not match. We're just going to take off the hello. Nice. Now that works. So we've implemented the hat, guys. We've implemented the start of line. That's great. Now what we want to do is the dollar. And now we just want to check. We want to check for the dollar, and here's what we're gonna do. We're gonna do it in match expr, and it's gonna be very simple. We're just gonna say, so if the length of our expression is greater than 0, if our expression of 0 is an end. So if we match everything, we've matched everything, and then we're at the dollar. And then we're gonna say, if we're at the end of the thing that we need to match, either we've matched everything, and if we've matched, so this means if either we've reached the dollar and then we have no more string to match. So string, there's no more string to match, so we've done it, and then we just do true match length. It's easy, we've done it. Or we still have stuff to match, but we have the dollar. So the dollar is saying end, but the string is saying keep matching. So we can't do that. So we just say false none. Right. So now that works. And if I am to add, if I were to add more stuff here, it wouldn't match, because sure, this matches, right? this matches, but then we still have some leftover stuff at the end of the string. Okay, so now this is correct. And now the last thing that I want to do, so very simple, is I just want to, let's say we want to be able to match a URL. So we're just going to say HTTP, we're just going to get the domain out, google.com, or like, let's say, we don't have a domain, but let's just say clumsycomputer.com/hey/there. Let's just have a like that URL, and let's just say we want to take the domain name out of here. What would be like an easy way to do it? Well, we're gonna match start, right, HTTP. Those are, we just matched it like that, and then we're gonna say how can we specify letters? Well, we can do A, B, C, D, F, G, H. We can do that, say all of the letters. It's a bit boring. It's kind of not cool. So we want to implement a special feature where well, we could do it. Absolutely, we could do it like this. We could do that, but we don't support that. And I think for this, it would be easier to just say something like this. Sorry, like this. So just a \A, an escape A will just mean letters. Easy. And then we can maybe also implement \D, let's say. So yeah, letters and numbers, clumsy0computer.com. Then dot, and then we're just gonna say com or net or org. And then we're gonna say anything, but actually we're just gonna say it's just gonna stop there. That's all we need to match. So what this is saying is we want to have letters and numbers, but we want to have more than one. And now it's gonna say unexpected token : so you see all of these things we need to pull out in here. You remember when I added this earlier and I said, hey, we're just gonna add some characters? Let's add those as well. Let's add the backslash as well. Wait, do we want to add the backslash? No, we don't want to add the backslash because that's going to mean something special. So now this all works, but then it's saying unexpected token and colon. Oh, sorry. Well, let's do this. Right. So I was just looking for it in that array of one element, which of course it isn't. So I need to look for it in the string with all the individual characters. Okay. Now it's saying, what is backslash? What is that? And you remember, I've said this so many times, that head, that kind of a unit thing that we did where we popped off something that could be longer or shorter. This is a unit. It's 2. It's length 2. 2 characters in length. And so what we want to do is just add something really simple. We're just going to say is escape character, return character equals, right, and then we're just gonna say def is escape sequence term, and then we're just gonna say return term return is escape the first thing in the term. All right, so now we can detect that, and then we can implement that in, this is a literal, or sorry, it's not a literal, it's a unit, I mean, sorry, or is escape sequence term, right? Oh, our line's getting a bit long, but it's still good. Is escape sequence term, and then that makes it a unit. And then in how to match a unit, or sorry, first in how to split an expression, we want to say or if it's is escape expr of 0. We're just going to say last expression position is plus equals 2, because we're moving 2 forward. Just moving 2 forward. And then we're just going to say our head is our expression up to 2. So that's going to be 0 and 1, length 2. Okay. That's it. And now we have our head. And now that we have that as our head, we just want to say how to match this unit. And we're just going to say if is escape sequence head. Whoops, let's just fix that real quick. If it's an escape sequence, we're gonna say, we're just gonna write it out very simply. If head is \A, then return head.isAlpha. Else if head is \d, we're gonna return head.isDigit. Easy. And then actually else, just gonna return false because we don't know what that is. So if I turn this into a \x, it's gonna say false. If I make that \a, still false. Interesting. Oh, I've just realized this doesn't make sense. We need a pipe there. This is still false. And let's see, why could this be false? That's interesting. So let's just say I make it just letters. Just letters. This doesn't match. Okay. So let's debug this by going print x per string. Do I need to do something? I think I do need, no, is unit, does unit match? No, that should be fine. So it's going all the way up to, I'm not sure why it's doing that. Let's see, so it's taking off that whole thing. I think I messed something up in the split expr, did I? It's not an open set, it's not, it's an escape thing, okay. Interesting. Let me just check. Did I do something weird here? No, that should be fine. Let me see, did I... That's very strange. Let's have a look at why that's happening. So let's do some debugging. Basically, let's just say is escape sequence. If this is true, print out our term. Just make sure that we're matching that. We're going to return true. So it is matching it. It's matching \a. That's good. It's very good. And then is escape, we use that somewhere. Or is escape, oh, is this the problem? No, this is fine. Is unit term, print is escape sequence term. That's true. So \i is an escape sequence. And then is a unit, does unit match, and then in does unit match, we're gonna find print head. Oh, okay. Well, here it's a very simple problem. This is always returning false. Because here I wrote, instead of writing string, the first thing in the string, I wrote head. So if you see here, we're checking that the first thing in the string of 0, that's what needs to match. It needs to match the first thing in the expression. And the first thing in the expression is this \, this escape sequence. And so the first thing in the string is what we need to match. So let's run that. And now it's saying, it's extracting it out, clumsycomputer.com. And in fact, we can even add numbers, clumsy123computer.com. You see, it extracts it out. But if we were to put an @ in here, it doesn't do it. And so I think this is it. So just let's go over what we did here. Basically, we implemented a regex engine that's based on backtracking. So it's not necessarily the most efficient in the world, but it supports the advanced features that we might want later. It was very easy to implement. It has the following features. It supports matching at any position in the string. It supports matching with like the hat and the dollar at the start and the end to match at the very start or the very end of the string. We added character sets, so you can say, so basically we can do ABC, you can do hat ABC dollar, you can do ABC 1 2 3 whatever. You can do alternate, so we can say cat or dog. We support that as well. For all of those things that we just mentioned, it supports these star and then question mark and plus. For all of those things, you can put them in front of anything. And we also added these like custom escape sequences for character classes. And I think that's about it. Let's see. We can also add our own characters here. So the operators work. We have the dot. We can add any escape sequence we want, so it's very extensible. we can add any literals. So here we can add any individual characters that we might want. And yeah, we support the alternates and the sets. And that's what our regex engine can do. Now, I think personally that as far as regex engines go, that's a really good feature set. That's a really good feature set. Because you know, if you use regex in Python or something, you know, you can have support for back references and things like that. But other than that, as far as basic regex features go, I think we've implemented more than a very basic set of regex features. We even have our own escape sequences and stuff like that, and if we want to have them match the ones in a different language or so on, that works. And you know, most importantly, I think, you know, we can extract URLs out of things and stuff like that, so it's really functional. Now in total, this was, let's just count the lines that are actually doing business here, 225 lines of Python code, and we had no imports. You see this up here? We didn't import a thing. We imported nothing. I really like that because, you know, we went through every individual step of how to implement this regex engine. We did every single thing ourselves. It was fun. At least I had fun. I hope you had fun as well. And now we understand how this works. We understand how to implement similar things. And if we are to use a regex engine, we kind of understand what it's doing under the hood. It's worth also reading about other ways to implement it, but you know, which maybe the sort of DFA, NFA way is also very interesting. But basically, you know, we did all that and now we understand this thing a lot better. I really like doing this because, you know, implementing, if you use a lot of libraries, and that's really cool. It's, of course, you can't implement everything yourself. It's extremely useful, but I think that you know, implementing something like this from scratch can make it, A, is super fun. You know, I think it's fun. And more than that, you can really, you know, understand how it works under the hood. And not just for, I don't mean just for regex engines, I just mean for other things as well. So I also like to do more things like this. If you guys have any ideas for what we could implement from scratch live on stream, let me know. So this is, if you're watching on Twitch, you're already here, but if you're watching this video on YouTube, where I think I will upload it to, this is from my Twitch stream, which you can probably find in the description. And I would love to see you around and let me know, you know, what should we implement from scratch. It'll be fun. I hope you liked this this implementation from scratch. No imports in Python of a regex engine that works really well, I think. And that being said, that is it. So have a good time. Have a good day. I hope you enjoyed this, and I'll see you around.